Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Our today's topic is RC and RL series circuit. So इस टॉपिक से पहले हम लोग इस चैप्टर नंबर 16 में alternating current through resistor, then AC through capacitor and AC through inductor, इन तीनों टॉपिक्स को डिस्कस कर चुके हैं और तीनों कंपोनेंट्स में अल्टरनेटिंग करंट के बिहेवियर को डिस्कस किया है। जबकि आज की जो दो टॉपिक्स हैं आरसी और आरएल सीरीज सर्किट की सूरत में, इसमें हमें इन कंपोनेंट्स के कंबाइंड इफेक्ट को डिस्कस करना है। When resistance and capacitor they are present in an electric circuit, and then resistance and inductor they are present in an electric circuit. So in these topics we will discuss about the resultant voltage, their impedance and phase difference. So before going to start these topics RC and RL series circuit, we must know about impedance. Impedance is the combined effect of resistance and reactance offered by resistor, capacitor and inductor. This is called impedance. यानी जब एक ही इलेक्ट्रिक सर्किट में ये कंपोनेंट्स प्रेजेंट हो इन द फॉर्म ऑफ रेजिस्टर, कैपेसिटर एंड इंडक्टर, then their combined resistance, their combined reactance is known as impedance, and it can be written as Z equal to VRMS over IRMS, where Z is for impedance. So impedance can also be defined as the ratio of RMS value of voltage to the RMS value of current is also known as impedance, and it is represented by Z, whereas its unit is ohm. Impedance की जो unit है वो ohm है, and 1 ohm is equal to 1 volt per ampere. So let me start our first topic in the form of RC series circuit. For this purpose, let me consider an electric circuit which consists of these two components: a resistor having resistance R, a capacitor having capacitance C, and both components are connected in series with an AC source having period T. T is their time period of that AC source. So this is an electric circuit where two components are present in series, resistance and capacitance, and they are connected with an AC source. We know that in series combination, the total voltage is divided. Hence, the voltage across resistance is VR, and the potential drop across capacitance is represented by VC, and their values can be determined as the voltage drop across resistance is VR, and it is equal to IRMS into R, where R is the resistance and IRMS is the amount of current passing through that electric circuit. Similarly, voltage drop or potential difference across capacitance, and it would be IRMS XC, where XC can be replaced with 1 over omega C. यहाँ आप इस इक्वेशन में XC को रिप्लेस कर सकते हैं with 1 over omega C, yani capacitive reactance and the frequency of AC source, they are inversely proportional to each other. So we have two values, one for the potential drop across resistance R and other for the capacitance C, which is IRMS over omega C. Now, in case of resistive circuit, we know that both V and I, यानी जब रेजिस्टिव सर्किट की आप बात करते हैं, और ऑलरेडी हम एसी थ्रू रेजिस्टर में ये चीज नोट कर चुके हैं कि बोथ वी एंड आई आर इन फेज, सो दे कैन बी रिप्रेजेंटेड इन वेक्टर डायग्राम सच एज, सपोज दिस इज द line draw for current I, and voltage across resistance, it is in phase to the current I, कि ये जो वोल्टेज ड्रॉप रेजिस्टेंस के क्रॉस है ये करंट के साथ इन फेज है. दे हैव नो फेज डिफरेंस बिटवीन देम, और देयर इज जीरो फेज डिफरेंस बिटवीन V and I in case of resistive circuit. But इन केस ऑफ कैपेसिटिव सर्किट, क्योंकि यहाँ इस इलेक्ट्रिक सर्किट में दो कंपोनेंट्स हैं तो हमें इनके कंबाइंड इफेक्ट को डिस्कस करना है. So in case of capacitive circuit, we know that voltage always lags behind the current by a phase difference of pi by 2. यानी कैपेसिटिव के केस में वोल्टेज करंट से लैग्स बिहाइंड होगी. So it can be represented here. So VC, which is voltage drop across capacitance, और ये करंट से लैग्स बिहाइंड है. करंट जो है वो इन दोनों के लिए कॉमन है, रेजिस्टेंस के लिहाज से भी और इधर वोल्टेज अक्रॉस कैपेसिटेंस के लिहाज से भी. सो विद रिस्पेक्ट टू वी आर दे आर इन फेज एंड फॉर वी सी दे आर आउट ऑफ फेज एंड देयर इज अ फेज डिफरेंस ऑफ 90 डिग्री बिटवीन them. So the applied voltage can be obtained by adding the vectors VR and VC. For this purpose we can use the vectors addition method. And there is a line parallel to VR. So we know that parallel vectors are always equal vectors. तो आप इस VR के parallel यहाँ ये line draw कर सकते हैं. Then resultant voltage can be obtained by drawing a line whose tail coincides with the origin and head coincides with the head of second vector. So this is the resultant voltage VRMS. And it can be determined by using the vectors addition method. So this is in the form of a right angle triangle. So by using Pythagoras theorem, VRMS becomes equal to base square plus perpendicular square and whole square root, where VR is the base of triangle and VC is the perpendicular of this triangle. So VR square plus VC square and whole square root is equal to the resultant voltage or the applied voltage which is provided by the source to these components. By putting the value of VR and VC, it becomes IRMS into R whole square, IRMS into XC whole square. In this equation, this IRMS is a common factor. So by taking common, it becomes IRMS into R square plus XC can be replaced with 1 over omega C whole square. तो ये IRMS कॉमन लेने के बाद आपके पास ये रिजल्ट होगा in the form of an equation number 1. Now, VRMS over IRMS becomes equal to R square plus 1 over omega C square and whole square root. We know that VRMS over IRMS can be replaced with impedance. लिहाजा आप VRMS over IRMS को Z के साथ replace कर सकते हैं, which is known as impedance of the electric circuit, and it becomes equal to R square plus 1 over omega C whole square and whole square root. So by putting the value of Z in equation number 1, आप यहाँ इसकी जगह पर equation 1 में Z put करेंगे, then VRMS becomes equal to IRMS into Z. So with the help of this equation, we can determine the resultant voltage, where VRMS is the resultant voltage which is applied by the source, and Z is the total resistance offered by the circuit, and IRMS is the amount of current passing through the circuit. इसके बाद आप लोगों ने इसी सर्किट में इम्पीडेंस को भी कैलकुलेट करना है, और इम्पीडेंस को कैलकुलेट करने के लिए हम इम्पीडेंस डायग्राम की हेल्प लेंगे. पहले जो डायग्राम बनाई थी उसमें जो वेक्टर्स रिप्रेजेंट किए गए थे, दे वर फॉर वोल्टेज अक्रॉस रेजिस्टेंस एंड द वोल्टेज अक्रॉस कैपेसिटेंस, बट नो दे आर रिप्रेजेंटिंग द रेजिस्टेंस एंड रिएक्टेंस रेस्पेक्टिवली. So by using this impedance diagram, we can calculate the total resistance offered by this circuit. For this purpose, again, we can use the vectors addition method. So there is a parallel line for resistance R, and this is the resultant known as impedance. So this impedance can be determined by using Pythagoras theorem, where R is base, XC is perpendicular, and their square and whole square root. So impedance is equal to R square plus 1 over omega C whole square and whole square root. So this mathematical form can be used to determine the impedance of electric circuit. Now, what is phase difference or phase angle? So phase angle, this is the phase angle theta. So this theta can be determined in this right angle triangle by using this identity tan theta, which is equal to xc over r, perpendicular over base. Then theta becomes equal to tan inverse xc over r. So here xc can be replaced with 1 over omega c. xc को यहाँ 1 over omega c के साथ replace किया गया. So by using this mathematical form we can determine the phase angle. थीटा आप मालूम कर सकते हैं. So theta is equal to tan inverse 1 over omega c into r. तो ये था आपका टॉपिक RC सीरीज सर्किट. Now RL सीरीज सर्किट. आरसी और आरएल सीरीज सर्किट, इन दोनों में रेजिस्टेंस तो कॉमन रहेगी. सिर्फ हमें कैपेसिटेंस से रिलेटेड तमाम फैक्टर्स को इंडक्टेंस से रिलेटेड तमाम फैक्टर्स के साथ रिप्लेस कर देना है. तो तमाम वही स्टेप्स हैं, तमाम वही मैथमेटिकल स्टेप्स हैं, उन्हीं को फॉलो करना है और सिर्फ आपने टर्म्स को रिप्लेस करते जाना है. सो फॉर दिस पर्पस लेट वी हैव एन इलेक्ट्रिक सर्किट व्हिच कंसिस्ट्स ऑफ अ रेजिस्टेंस and an inductance, and they are connected in series with an AC source having period T. So this is an electric circuit which consists of two components, resistance and inductance. Again, in series combination, the total voltage is divided across these components. Voltage drop across resistance is VR and across inductance is VL. ये सीरीज में ये टोटल पोटेंशियल डिवाइड हो गया. Voltage drop across resistance is VR and is equal to IRMS into R, whereas voltage drop across inductance is VL and it is equal to IRMS XL, where XL can be replaced with omega L. Or inductive reactance or frequency of AC source, they are directly proportional to each other. लेकिन कैपेसिटेंस के लिहाज से, कैपेसिटिव रिएक्टेंस के लिहाज से इनवर्स रिलेशन था, यहाँ डायरेक्ट रिलेशन होगा. सो बाय यूजिंग दीज वोल्टेजेस we know that again in case of resistive circuit, V and I, they are in phase and they are represented in this diagram. So VR and I, they are in phase, they are acting along the same line, they are representing zero phase difference between them. But in case of inductive circuit, we know that voltage leads the current by a phase difference of pi by 2. इंडक्टिव सर्किट में वोल्टेज करंट से लीड कर रही होती है और दोनों में पाई बाई 2 का फेज डिफरेंस भी होगा. सो इट कैन बी रिप्रेजेंटेड हियर. टू गेट द रिजल्टेंट voltage or the applied voltage, we can use the vectors addition method. So by repeating the same process, there is a parallel line of VL and the resultant can be drawn by drawing a line whose tail coincides with the origin and head coincides with the head of second vector. So this is the resultant voltage. So by using Pythagoras theorem, VRMS is equal to base square plus perpendicular square, where VR is base, VL is perpendicular. By putting their values, VR which is equal to IRMS into R and VL which is equal to IRMS into XL, where XL can be replaced with omega L. आप यहाँ XL को omega L के साथ भी replace कर सकते हैं. इसमें आप नोट करेंगे कि IRMS कॉमन है, तो कॉमन लेने के बाद R स्क्वायर प्लस XL स्क्वायर एंड होल स्क्वायर रूट, दिस इज इक्वेशन नंबर 1. एंड VRMS ओवर IRMS, इस IRMS को आपने यहाँ लेफ्ट पे शिफ्ट कर देना है. सो VRMS ओवर IRMS becomes equal to R स्क्वायर और XL को ओमेगा L के साथ रिप्लेस किया गया है. And we know that the ratio of VRMS and IRMS is known as impedance. represented by Z and is equal to R square plus omega L square and whole square root. So by putting the value of R square plus omega L square equal to Z in equation number 1, we obtain Vrms, which is the applied voltage, and is equal to Irms into Z, where Z is the impedance of the electric circuit. And this impedance can be determined by drawing the impedance diagram. तो impedance diagram में resistance horizontal के along, जबकि inductive reactance vertical के along है, and there is a phase difference of 90 degree between them. So again, by using the vectors addition method, this impedance is equal to R square plus XL square and whole square root, where XL is replaced by omega L. तो XL को आप यहाँ omega L के साथ replace कर देंगे. So this is the impedance of RL series circuit. Phase angle, which is represented by theta. So this phase angle can be determined by using tan theta equal to perpendicular over base, where perpendicular is XL and base is R. So tan inverse XL over R is equal to phase angle, and XL can be replaced with omega L over R. So इस फार्मूले के जरिए आप इसके फेज एंगल को डिटरमिन कर सकते हैं. तो ये थे आपके दोनों टॉपिक आज के, आरसी एंड आरएल सीरीज सर्किट. तो इन दोनों इलेक्ट्रिक सर्किट्स में आपने देखा कि दो कंपोनेंट्स यूज हो रहे हैं, जबकि इससे पहले हम हर एक कंपोनेंट को अलग से डिस्कस कर चुके हैं, यानी एसी थ्रू रेजिस्टर, एसी थ्रू कैपेसिटर और एसी थ्रू इंडक्टर की सूरत में. जबकि यहाँ इन इलेक्ट्रिक सर्किट्स में resistance and capacitor, they have combined effect, and then resistance and inductor. Thank you.